Hi guys, Mrs. Suya here. This video is going to cover the difference of perfect squares factoring pattern. So just a reminder that to factor means that we are going to write an expression in its pre-multiplied form. So to begin with, we're going to actually multiply these two binomials together. All right, so these binomials are kind of special because they both have an x as the first term, and then they have the same number as their second term, in this case, 8s. One is addition and one is subtraction, so we call it a sum and a difference. So when we multiply these out, something special happens. So we have to go through our FOIL pattern, first, outer, inner, last. And what we see is that the outer and inner terms that are generated are identical, except they have opposite signs. So this is going to make them completely cancel out. They go to just a 0x, which means we don't write them at all in the final answer. And we just are left with these two terms that are also very special because they are perfect squares. So the first term is a perfect square, x squared, and the second term will always be a perfect square because when we start with our sum and difference pattern, we're always going to have the same number in the second position. So that's always going to generate a perfect square. So this pattern is called a difference of perfect squares. Difference meaning a subtraction. So you can see that there is no way to generate a plus sign in between, because with these opposite signs up here, we're always going to end up with a subtraction for our last term. All right, so these two phrases are important. They are related to one another. So if you start with a sum and difference pattern and you multiply it out, you end up with a difference of perfect squares, which means if you start with a difference of perfect squares and are asked to factor, then its pre-multiplied form is going to be a sum and difference. So here's a quick example. This one says x squared minus 100. So the first step is pattern recognition. First of all, we have a perfect square minus a perfect square, which means we have a difference of perfect squares. So we just have to memorize that a difference of perfect squares will always factor into a sum and a difference. All right, so we're just going to take the square root of that first term, which will be x and x, and then the square root of the second term, which will be 10 and 10, and we are finished. They're actually very easy to factor once you have the pattern memorized. It's just you have to recognize and memorize the pattern. Okay, 3 examples on this next screen. So now we have a number attached to our first term, but notice that it is also a perfect square, and we just need to have our pattern recognition. The first term is a perfect square, and the second term is a perfect square, and it's subtraction, so it is a difference of perfect squares pattern. So it is going to factor into a sum and a difference. And now we're going to take the square root of the first term. So you have to have a perfect square in that number right there, so we can split it into 2x and 2x here. Square root of the 9 is 3, and we're done. Just a quick check. We're going to go back to check it. Remember, if we multiply it back out, it has to equal what we started with. Otherwise, we factored it incorrectly. So when we go first, outer, inner, last, the outer and inner terms cancel, and we're just left with the first term minus last term. Okay, next example is also a perfect square minus a perfect square. So 49 looks a little strange in the front there, but it is a perfect square. So we're going to break it into 7x and 7x. And 1 is the forgotten perfect square, but its square root is 1. So we'll have 1 and 1 in those second positions, and we'll be done. Okay, so the last example, x squared plus 16, is actually not a difference of perfect squares. It's a sum of perfect squares. And this pops up enough, and students kind of misfactor this enough that I wanted to just show an example of this. So here is a really common way to factor this. And here is another common way that students want to factor this. Both of these are incorrect. So let's look at this first one. So this first one, you would be thinking that you could just take this exponent and distribute it to the x and the 4, and you would have x squared plus 16. And that means that you are misusing an exponent rule. So when you have a binomial like this, as in something with a plus or minus sign in between here, you would need to, or you are not allowed to distribute an exponent over a plus sign like this. The correct way to simplify x plus 4 squared is to take this number x plus 4, and since it's being squared, times it by itself. So you would expand it into this. So these two are equivalent expressions. Neither of them are actually the correct factored form of x squared plus 16. So let's go ahead and just kind of investigate why it doesn't work. We're going to just check this with FOIL. When we do our first outer, inner, last, we realize that the OI term, the outside and the inside, are both positive. So without any minus signs in there, there is no way to cancel that middle term. So even though we generated a plus with the 16, we have a middle term. So this is not what we started with, which means this is not the correct factored form of x squared plus 16. And in the end, the answer is that the sum of perfect squares are not factorable. All right. Good luck, you guys, with your own factoring. Thanks for watching.